This episode of Hak5 is brought to you by Domain.com. He's Greg. Hey everybody, welcome to this episode of Hak5. My name is Shannon Morris, and this is your weekly dose of Technolust. You may be wondering why I have Dinosaur Greg here instead of Darren. And the reason is because Darren is on his quest for awesomeness over in Europe. You can follow all that information over at hackacrosseurope.com. And he's also a little bit under the weather, so I didn't want him to come in here and contaminate the entire studio. By the way, this episode is releasing the day before his birthday, so make sure that you wish him a happy birthday, okay everybody? Just go on Twitter and just destroy his entire Twitter stream with happy birthday wishes. So we have a lot of fun stuff happening on this episode, so how about we go right into it and check it out. Hey everybody! So Darren's gone this week. He's not going to be joining me on my segment, but I wanted to have a little bit more fun with my Arduino. So you guys probably remember last week when I played with that potentiometer to make my Cylon. Well, that involved dealing with these new pins, which I haven't really played with that much yet, so I just decided I should probably figure out how these work. So this week I wanted to talk about the differences between these two sides of pins. So one side is digital and one side is analog. So these can be used for inputs, either analog inputs or digital. So digital read, which we've been using in our code, this is which we've been using for everything from turning a button on and off to making the LED blink, just simple stuff like that. It's great for button interaction, but if you have something like a light sensor, which I'm going to play with today, which triggers an action whenever it senses light, or if you have a temperature sensor, stuff like that, it requires this thing called analog read. So analog read is going to tell you how much light is being sensed through the light sensor, not just if it's on or off. So that's the big difference between analog and digital. Yay! So these can be used for temperature, they can be used for light changes, anything that involves a change in a range as opposed to just on and off. So we also use this for the potentiometer, as I mentioned before. What I did in that case, I just plugged it into the analog A0 pin, and then I triggered the function by moving the button to change the speed of the LED flash. And it reads how fast it's going to go, not if it's just on or off. So for my first demo today, I'm going to have two different demos with two different versions of my code. This first one is just going to be a simple flashing LED. So if we want to look at my little Arduino over here, I'll show you exactly what's going on. So first off, we have our Arduino. It's plugged in by a USB, and then we have my breadboard. So if we look at the pins on the Arduino, we have one wire going directly from a digital pin over to the LED. The LED has a resistor, which is tied to ground, and that's going over to my ground pin on the digital side. Then we have the light sensor. So this is the little light sensor right here. It's a very, very small component, but they all look the same. They have squiggly wires at the top of them. It's pretty easy to tell which one's a light sensor. So that one has a resistor. The resistor is going all the way over here, and that one is going to, I believe that's ground. We have one wire that's going to 5 volts, and then we have the other one, which is going to A0 in this case. So we have analog 0 for this light resistor. So when I have it just on regular light that you see in this room, it blinks on and off at a decent rate. If I cover it up completely, it blinks faster, so you definitely see a change there. And then if I use something like this little flashlight here, and put it directly on the light sensor, you'll notice that the LED goes really, really slow. There we go. So it goes crazy slow. So if you want to do this demo, for example, I'll show you my code really quick right over here. All right, so it's a very, 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 very short code. First off, you put your constant int in for your LED, whichever pin is going to be. In my case, it's 9. The int value equals 0, so this sets the value of the sensor. And then you just have your setup, which is going to say the LED is the output. So this is all very similar. And then we go down here to void loop. So this is going to be our loop, which plays again and again until we unplug it from the power. First off, we have analog read, which is going to read the sensor value of A0. There's the 0. Digital write is going to be the LED, so it'll turn it on. It'll automatically stop the program for a very short time, and then turn it off, and again stop the program for a very short time. So you actually see a change in that on and off in between whenever it's on. So you can see it whenever it's blinking faster or blinking slower. So pretty easy to do in that case. Now I'm going to go ahead and load my other code real quick so you can see the difference with this one too. This will take a couple of seconds for it to load, but I'll go ahead and run through the code for you. In this case, all this up here is still the same. Setup LED is going to be the output, LED is still equals 9 for pin number 9, the value still equals 0 for the sensor, and that just sets it up. Down here, the loop is a lot shorter. In this case, it says analog read is going to be A0, so that just reads the sensor value again. And then we have this weird line here that says analog write LED value divided by 4. So this is going to turn the LED on to match the brightness of the sensor, and then we wrote in a delay of 50 milliseconds in between each time it reads the value of the sensor. So this one looks a little bit weirder, but hopefully we can pick it up on camera. So I'll go ahead and pick this up. All right, so first off, in the room, it's a decently bright LED. If I cover it up, you can see that it dims along with how dim it is on the light sensor. So it tries to match the light sensor. If I put the flashlight over it, it should get brighter, and it does. So it gets just a little bit brighter. You can see a very, very small difference in it whenever I do that. And hopefully you can see that on the camera decently. So not a huge change, but you can tell that the LED is going to change depending on what's happening with the sensor. So the reason I wanted to bring up this value divided by 4 thing that you saw in my code, this is kind of weird, but I'm going to try to explain it as best I can. Analog read can go up to 1,023 different like computer language bits or values. The values are from 0 to 1023, which is going to be 1,024 different values total. So analog write accepts up to 255. We remember when we did our brightness one, it was able to go up to 255 brightness. So value divided by 24, value divided by 4, which is going to be 1024 divided by 4, equals 255.75, which is pretty close to 255. You can also do the same thing with 1023 if you wanted to. So analog signals can read up to 1024 different signals between 0 volts and 5 volts on an Arduino. So if I'm using a temperature sensor, for example, and this is explained very, very well on the Arduino website as well if you want to read it up on there. So say I have like a temperature sensor that does either Fahrenheit or Celsius, depending on which one you live in. So the reading would have to be transitioned into something that the Arduino is going to understand. Because if you stick a temperature thing on there and you just say, hey, I want you to read this out as, 120 Fahrenheit or whatever it might be. That would be really, really hot. It's not going to get it. It's going to say, you have to give me a value between 0 and 1024 or 1023. So you have to give it one of those values. Same goes for LEDs with a light sensor. The light sensor can trigger up to 1024 different values that will be understood by the LED as 255 different brightness levels. Haha! So that's why we have that value divided by 4 in my code. So I know this was really quick and easy, but I just wanted to kind of round it out and give you an idea of what the differences are between these inputs and those inputs. Of course, there are a lot of other differences, but that's the main one that I've been running into, so I just wanted to explain it real quick. And we're going to move on. We're going to have a little bit of trivia after the break, so stay tuned.
It doesn't matter if you're a fan of free candy, or OpenSky, or Tetra, or Logic Link, or a turkey, or if the open source encryption software has been made by the government the whole time, or obfuscated, or a frame, or if a packet hits a pocket on a socket on a port, or free mustaches. If you have a conspiracy theory, you need to snag a domain name and web hosting fast. Boom, up and running. You need a website. A website needs a domain, and you can get those over at domain.com. Then get this, domain.com, they get a very quick domain discovery system and a very easy checkout process. And you know what that means? Boom, up and running. I don't know where this is going. Did you know the first female pilots were called aviatrix? Whoa! The guys over at domain.com huge fans of Hak5. And I've told you time and time again, guys, domain.com is awesome because they're affordable, they're reliable, they're easy to use, they're super fun, but mainly because they're a fun place to do business. They're active on social media. You can tweet them at domain.com and see why. It's just, they're fun guys. Boom, up and running. They're so much fun to do business with. These guys are zany. These guys are fun and crazy, and they love Hak5, and they want to hook you up, so that's why they came out with a very easy to remember coupon code for Hak5 viewers like you. It's called HAK5, and it spells Hak5, and with it at domain.com's checkout, you get an extra 15% off. Whoa! And when you think domain names, think domain.com. Is that right, Bear? Yeah, see, Bear agrees.
We are back and it's time for trivia. My favorite part of the show, sometimes. Last week's trivia question was, how many of the first Apple computers were built? And the answer is 200. I know, that was an easy one. This week's trivia question is, what was Mario's original name? If you don't know who Mario is, just Google Nintendo, you'll figure it out. Answer that over at hak5.org/trivia for your chance to win some awesome Hak5 goodies. Good luck. I know, Greg, and then all that crazy stuff happened in the warehouse, and then I saw that fire. I know you didn't start it, but that's okay. I mean, I won't tell anybody if you actually did start it. Are you live? Oh crap. Don't tell anybody that I told. It was Greg's fault. I didn't start the fire. Don't tell Darren. That's about wraps up this episode of Hak5. You can find everything that we do over at hak5.org. Of course, if you have questions or comments, or you want to tell me more about what I'm doing with my Arduino, definitely hit me up, feedback@hak5.org. And of course, if you want to support us, Hakshop, hakshop.com. We just put in some really cool bundles, so definitely check those out. And we have all the originals, the rubber ducky, the Wi-Fi pineapple, and all that fun stuff. And last but not least, of course, again, check out Darren on all his adventures in Europe, hackacrosseurope.com. I'm Shannon Morris, and this has been your weekly dose of Technolust with Hak5. Remember, guys, and remember Greg. Maybe he should say it this week. Do you want to say it? Do you want to say the slogan? Okay. Trust your Technolust. Bye!